Hi, I'm Timoni West, and I'm the Director of XR Research at Unity Labs. And today we're going to be talking about a few key things to help you make excellent virtual and mixed reality experiences. First, we're going to talk about inputs and outputs for human-computer interaction, best practices, some great examples of UI and UX, and finally, talk a little bit about the future of spatial computing.
Hi everyone, thanks for coming. I know it is almost beer o'clock, so I appreciate you being here today instead. Before I get started, I'd like to get a sense of where you're at in terms of familiarity with AR, VR, MR, which we call XR at Unity, mainly because we're lazy and we don't want to have to say all the words every time. So how many people know what Unity is or use it or another game engine? So about 3/4, okay. And how many people have made a virtual reality experience before? Wow, okay, wow. That's like more people than raised their hands that said they used a game engine. So I have questions for you later. How many people have made an augmented reality experience? Okay. And of that, keep your hand up if you made augmented reality, and keep it up if you made it for a HoloLens or a Magic Leap. 1, 2. Okay, only a couple. All right. Yeah, I get it. It's hard to make builds. Okay, so today I'm going to go over a few different things. We're going to talk about best practices for XR, take a deep dive into different types of modalities and why you would use them and when you would use them, and talk about the future. That's fun. So here's the agenda for today. First, I'm going to talk briefly about the current state of hardware and software. It looks like most of you are aware, but it's always good to do an update of the ecosystem. I realized myself that there are so many new virtual reality headsets out that I hadn't even been thinking about. Then we're going to go over modalities and design systems, specifically for XR. And then I'll have some concrete examples. And I decided to do a deep dive, since we have so much time, into one particular thing, selection, which I think it's the basis of all human-computer interaction, and yet people don't really think about it very thoughtfully or often enough. They usually just copy what they see other people do. And then finally, we're going to talk just a little bit at the end about the next steps for spatial computing and what we're thinking about. I have a couple of other talks that I'm happy to link people to where I go deep into the spatial computing stuff in the future, and I'm happy to talk about that later. But I wanted to keep this one practical. So first, let's talk about the current state of hardware and software. And by the way, I would love, if you have questions as I'm talking, please feel free to raise your hand, and we have microphones. I would like this to be as interactive as possible and make sure that if you don't understand something that I've said, that I can clear it up, or if you have thoughts around it, would love to hear them too. My title is Director of XR. Augmented reality, mixed reality, virtual reality, and spatial computing, all of these things can be on a very specific continuum. So I want to just talk briefly about when I say these words, what I mean, and feel free to disagree with me on Twitter or Reddit all you want. So when I think about VR versus AR versus MR, virtual reality is you stepping into the digital world and being completely enveloped by it. You don't need to have any sensors, really, other than cameras pointing at tracking you in order to feel like you're actually in the space. I hear there's going to be drums playing upstairs, so if you need me to talk louder, let me know. I think of AR today pretty much as mobile AR, where it's a rendered opaque frame that has a camera feed pointing in, so it looks pretty translucent, but it isn't. In other words, it's still completely digital, everything that you're interacting with. And then mixed reality is when you have a semi-transparent overlay, where you can actually be projecting into your eyeballs, but it looks like the digital object is in space. And the entire frame isn't rendered, it's only rendering the digital part of the objects. Does that make sense? Everyone get that? Okay, all right. Okay, so this is what we have on the market today for virtual reality headsets. So this chart is not to scale at all, but at the low end we've got, PSVR, it's been around for a long time. We have the Quest, Focus Pro, getting over into the higher-end headsets that require a computer. These are all standalone computers. These all require a computer. a large PC in order to work. And at the very, very high end over here, pretend this is like way further down, is the Vario headset, which is almost truly 4K with foveated rendering, but it also costs 6,000 American dollars. So this costs $400. So you can see there's quite a gap there. Does anyone have the newest headsets? So the Index or the Rift S? Anybody? No? Okay. All right, so that's kind of the landscape today. I actually didn't include many of the other headsets on the market. I just wanted to include these because these are either best in class or top selling or the most kind of interesting ones on the market today. When it comes to augmented and mixed reality, we have like nothing in comparison. So if you want cheap, and I use that very loosely because phones are expensive, phones are more expensive than most VR headsets. You've got, Android and iPhone and Huawei. And then on the high end, you have sort of the older HoloLens kind of here, which was actually more pricey, but now is less good. It's the older generation. And then over here, we have the Magic Leap, and we have the new HoloLens 2. And these are the best in class that we have today for mixed reality headsets. And they are essentially all we have, other than whatever is happening in closed doors, at other FANG corporations that they haven't released yet. So I just want to talk a little bit about how these work. I'll dive into this a little bit more deeply in a second, but just to give you a sense of how the virtual reality headsets know where you are and know how to track you. On the low end, they have what's called inside-out tracking, which means the cameras are on the headset pointing out. Sometimes they can track the controllers. Sometimes they're just kind of tracking 3DOF. Mid-tier, by which I mean things like the Rift or the Vive, always have outside-in tracking, which means they have either infrared lasers that are pointing at you or an infrared camera that's tracking infrared LEDs. And then for high-end, it depends on if it's VR. If it's VR, it's outside in again, and if it's AR, it's inside out, because both of the major AR headsets or mixed reality headsets are self-contained. They don't need to be tied to a computer. And for displays, the highest we've got right now is limited 4K. And that's only in the center of your field of view. And there's only 2 headsets on the market at all that have that, the Vario and one other headset that I don't think you can purchase yet. I mentioned this earlier with the other slide. Are they standalone? Yes, for low end, it doesn't require another computer, which means it's basically just a super souped up phone. And by the way, the high-end mixed reality headsets are also basically just souped up phones. They're all mobile hardware, pretty much. For mid-tier, usually it requires a PC, and then for high-end, again, for VR, no, it also requires a PC, but for AR, they're their own thing. And then finally, world sense. And this is where virtual reality and augmented reality and mixed reality all start to collide. Low-end headsets might actually have more world sense than some of the high-end ones. When I say world sense, what I mean is cameras facing out that are finding out depth information or plane information or doing pass-through. I'll talk about this a little bit on the next slide. Anything that lets the computer know, wherever that computer is, something about the space that you are in. And for high-end headsets, things like the Vive Pro do have pass-through cameras and can generate a mesh, but it's low latency. You can't use it in real time, unfortunately. And for AR, this is the best-in-class. It doesn't have the best-in-class GPU, and it doesn't have the best-in-class rendering, but it always has the best-in-class world sense. The Magic Leap, I think, has something like 16 cameras on it, because in order for mixed reality to work, it needs to know as much about the world as it can. So I started to make a mind map of all of the world awareness types that you get in different systems, and I ended up with this, which you can't read. So this will be included later on as part of the things that you can download. I'll have this available. The thing that I realized is, for here, this is just common world-aware devices. I only picked 3, right? These are probably the 3 most common things you might have in your home, and the odds of you having an HMD are very slight, right? But for phones, you've got cameras, you have the network information, which gives you GPS, you have touch detection, 2 different kinds, capacitive and resistive. You have photodetectors that are used for things like proximity information, so it knows where your face is, so it knows to turn off the display if you're taking a call. You got different types of microphones for different things, accelerometer, gyroscope, magnetometer, thermostat, and a barometer, which I didn't know we actually had. And then when you get over here into HMD land, depending on the device, it's cameras, cameras, cameras all the way. Cameras that are tracking you from outside in, cameras that are on the headset, and then cameras that are what is this? Oh, table mounted, also for tracking other types of information. And even within the headset, we've got what types of things are being tracked and how. So it could be depth information, it could be frame analysis for things like hand tracking, like it's all over the place. Example tech stacks. This is more, I focus more just on augmented reality here because if I wanted to talk through every single tech stack for every single device, we would be here until 10 p.m. at least. So this is just focusing, this is focusing on augmented reality specifically, or mixed reality. So if you're Microsoft and you're working on the HoloLens, you have two main platforms that developers can use tech stacks to take advantage of. The first is their mixed reality platform, and this has been around for a very long time. This is what, if you make a HoloLens app, you will use. And alongside all the things like rendering and the basics of getting a build on the device, it also has things like speech input, the vision stuff, and then, of course, all of the specialized rendering for that specific device. Now, Azure has become a much bigger play over the last 2 years for Microsoft, maybe even more. And they've actually combined the HoloLens team and the artificial intelligence team in the last year. So Azure gives you things like cloud anchors, which they announced earlier this year. And the cool thing about cloud anchors is they let you be in a HoloLens, someone else is in a HoloLens, and now you can look at the same thing at the same time, record that information, record the room, go into someone else's room. This is that sense of persistence that makes mixed reality really magical. So that's a new thing that they're offering as of this year. Digital twins, that's more for industrial, if you have a real world object and you want a digital equivalent of that object. And then remote rendering. Remote rendering, how many people are aware of remote rendering or have used it or know about like Google Stadia? Nobody? Okay. I want to talk about this for a second then because it's really important for the future of computing. Earlier this year, Google announced a new product called Stadia that renders frames in the cloud that can then just go down to your device. And this is an example of edge computing that I think people are most familiar with. The reason why I think this is so interesting is because this is the first chance we have to have a compute session that belongs to you that happens in the cloud that can be rendered on ultra-fast computers, and the only thing that you need is a lower-powered device that maybe has encryption information or maybe has some sort of machine learning running on it. So I could look at my laptop, and it has face detection, and it knows it's mine. And then if my friend Kevin were to come on stage, and it saw his face instead, within a frame render, it could switch to being his compute session and his computer. And that's really exciting. Okay, so that's Microsoft. And then for Apple, how many of you have made an AR app for ARKit, with ARKit? 1, 2, okay, like 5 or so. If you do that, you use ARKit, which was running some machine learning using Core ML, which is Apple's kind of answer to TensorFlow, mobile machine learning. And now the newly announced Reality Kit, which you can use Reality Composer with as well. And this gives you things like specialized rendering for AR. Oh, and the reason why these are grouped together is because these are holistic tech stacks, hardware and software. So you get both, right? You get the HoloLens, you get the iPhone. And down here in mostly software land, you have Google, which has a pretty equivalent offering to Apple. So they've got TensorFlow for machine learning, AR Core as opposed to AR Kit, but they have really similar features. And then Google Maps actually has released their own spatial anchors as well that are similar to the cloud anchor offering that Microsoft has. And then over here we have Facebook. And I wanted to bring up Facebook into this particular slide because it's interesting. Facebook lets you make AR, but most people don't think of it as AR, and they did this on purpose. They have face masks. They have games you can play. If you have a portal, the portal can track you and have the camera. This is augmented reality, right? This is just as legit as anything else. The big difference is you can only access this not through a developer kit or SDK, but only through their own authoring tool, Spark AR. And if you're trying to make an Instagram filter, it's actually limited to a certain subset of artists. They have some APIs, and then they do have a hardware offering, kind of, with the portal. And I actually think the portal is really exciting. Does anyone have one? Okay, I get it. Facebook and data is quite the conversation right now, but I do think Portal is cool because it is this kind of stealthy, truly augmented reality app that people use regularly that feels really familiar and uses AR in a practical way, and it's something you might give to your mom for Christmas. So I think it's a really cool step into the future. Okay, this is kind of the same data, just said a different way, but I thought it would be useful for everyone to be able to see it in a nice little chart here. So Apple, Facebook, Unity, and Google, core software, ARKit, Core ML, their creation tools, Reality Composer. You can only publish to the App Store. You can't publish an Apple app to Google, unlike the reverse. And is it hardware agnostic? No, you can only publish, or you can only run this stuff on Apple's hardware, right? Facebook actually is hardware agnostic. You can publish to both an iPhone or Android. Actually, mad props to Facebook. They support their augmented reality machine learning works on Androids back to 2012. So they actually have some of the most performant machine learning augmented reality technology out there on the market. Unity, of course, and a lot of you knew what that was. We have tons of external SDKs that we partner with. That's kind of our big thing. And my team specifically is working on a new product called Project Mars, Mixed and Augmented Reality Studio, which makes it a lot easier to make mixed and augmented reality. I'll talk about it a bit during the end, but you can use Unity for mixed reality and augmented reality today, but we're really trying to streamline that process because it gets really difficult. Publish it. We can publish to everything but Facebook and Snap right now, just because they're closed ecosystems, so they don't let you, you have to use their tools to publish. And is it hardware agnostic? Yes, we are. For Google, AR Core, TensorFlow, you can use SceneKit. Like everyone else, you can publish everywhere except for Facebook and Snap. And are they hardware agnostic? Kinda. If it's an Android device, then it can run Android. One other thing that I want to mention too is, since we're going to be diving into selection later on, I just wanted to show all of the different controllers that are out there for all of the HMDs today. Kind of the very early ones were these two, the Rift and the Vive controllers, and they pretty much look like you took a game controller and you split it into two, and you added a bunch of tracking bands on it, and there you go. These are the new ones. These are more refined. So this is the knuckles, the Steam knuckles, and they actually have much more robust finger tracking, so direct finger tracking. And these are for the new Oculus headsets, and they're just lighter and easier to track. And then on the far end here, we've got the Magic Leap controller, which is, as you can see, is really simple. It's actually much more analogous to a low-end VR controller. And then down here, we have the Windows Mixed Reality controller, which I think looks the coolest because it emits actual visible light. A lot of people think they diss it, but I don't know. Come on, it looks futuristic. We're working with future tech. Let's embrace it. All right, this means it's kind of a tremendous challenge to anyone who's ever worked with a game console, but then now also wants to make an experience that makes any kind of sense across different devices. You have to do a lot of remapping and rethinking of what now goes where. How many people have made a game or are a game designer? No? Yeah, one? All right. So when it comes to making a game, it comes to making anything, we'll talk about this later, you got to map your nouns and your verbs, right? So you might have a verb like swing a sword, and that maps to the B button. Computers have been standardized around our basic interaction patterns forever. Hotkeys you can kind of go nuts with, but if you click the mouse, that's usually a primary action. Whatever mode you're in, that'll be the first action. So figuring out how to map these together and what is primary has been a long conversation. Is it the trigger button? Usually is. Is it the secondary trigger? Is it the A button? That's TBD. And I don't even know what to do with this, which is the HoloLens interaction pattern. I mean, they have a whole system. They know what to do with it. But how this maps from what we saw on the previous screen to what people are doing now, I mean, this is a conversation to be had. I don't know. And then, of course, we've got the phones, which is how most people actually work with mobile AR today. And we have to think about how you interact with things that are digital, that in theory live in the real world, but you're also covering them up with your hand at the same time. Talk about that. Modalities and design systems for human-computer interaction. This is my favorite part. All right. There are three basic types of input-outputs in computing. And the input-output loop is known as a modality, and that's how I refer to it. They are visual, they are audio, and they are physical. And these are 3 of your 5 senses. The other 2 are taste and taste and smell. And I don't want to use those as inputs or output personally. You can if you want to. All right, we're going to have to go through the pros and cons of these, the big 3, the ways that most people are ever going to interact with a computer in their life. Examples for visual, we have things like poses, how you're standing, if a computer can see you. Graphics, text, UI screens, animations, you all know this. For auditory, there's music, there's beeps, there's tones, there's sound effects, there's all of the little cues that tell us that our tiny little pocket computer just got an email, or someone Slacked you, or someone Facebook messaged you, or someone telegrammed you, or your mom just texted you, or someone called you, and you have a missed call, on. And physical, obviously, the hardware, the buttons, the haptics, and the real objects that are tied to computers. So this is a classic example of a typical smartphone. Smartphones are designed to be visual only. Like, they're designed to work really, really well without sound or anything else. And so the way this works and why motion graphics has become increasingly popular for application and design is because if you see things moving, you can follow it more easily. You don't need the other modalities as much. Physical affordances are minimal to none, especially since the iPhone got rid of the home button. Lots of new animations instead. This takes the place of what otherwise could have been a noise. But when it comes to phones especially, you can never trust that people have the sound turned on. There are a lot of advantages to visual modalities, to making everything visual first. First, text is inherently a 2D medium. So if you have a lot of text, it's good to have it be visual. Text really works well with visual. People know how to read. You can express a lot of information visually. That is what I meant to say. I'm sorry. It's also extremely customizable. With audio, you kind of have to be a little bit more realistic because audio is very much tied to physical. If I drop something, it should make a sound like it was dropped, and it actually lets me know things like the weight of the water bottle hitting the wood, and from how it bounced that this was made, or how it sounded that this was made of plastic, not glass. And that's why I mean that visuals can be extremely customizable because you can extend kind of beyond those bounds of expected behavior, physical behavior. And it's very high fidelity compared to sound or haptics, insofar as humans are able to take in a lot of visual information. Now, by the way, when I talk about these types of inputs, it is all with the caveat that disability is a huge conversation. So if you're blind or partially blind, obviously this does not apply to you, and you're going to lean more heavily on the other modalities. Unfortunately, disability is such a broad conversation that there's no way to cover it as like its own category. It's what kind of disability? Are you missing a limb? Are you deaf? Are you blind? Each of those deserves, frankly, a lot more conversation in of itself. Microsoft has actually done a lot of good work around describing different types of disabilities. I encourage you to check out the stuff they've done. There are, though, a lot of disadvantages to visual modalities. If you've ever played a virtual reality game, there'll be often like a lot of text and a big sign to look here, and people will be like, I don't know, what do I do? And you're like, really? It's like the size of a fucking building. Like, just look to your left? No, you're not going to look to your left. Okay, so it's tied to space unless you actually physically put it in front of people. Visual stuff is just easy to miss. Visual stuff is also just more higher level in the brain. The prefrontal cortex is what does the processing of all of the written communication and a lot of our iconography as well. So if you want someone to run away from something, if you want someone to respond instantly, a better way to do that is with the more physical modalities, which are sound and touch, right? You will, if you feel a haptic feedback in a controller, you will process that more quickly than your brain will think, oh no, the monster's coming, I need to run away. As input, there's really only one kind of visual input right now, and it is gestures, which most people don't think of as a visual input at all. But if I'm using the HoloLens and I'm going like this, it feels like a physical input type, and yet it is not, because the camera is looking for a specific movement or pose. So when I say that as input, visual is very tiring, I'm saying it is tiring to have to sign language with your computer constantly. So use it with caution. Audio, the best example I could think of for audio modalities being the primary modality is in a surgery room. And this is when you have to be looking a specific location and your hands are also tied up in a specific location. The cool thing about audio is that it is omnipresent, and it's actually hard to get away from unless you have the sound muted. So if you can't see anything, if you can't look away, audio is the best way to get information to people. and it also is great for continual back and forth updates. It's also pretty high word per minute, not as high as visual, but sometimes that's okay if you just need something responded quickly. It's easy to make things feel more real using audio, and it can be super, super subtle and work really well. If someone has their phone on and it dings with a tone that we recognize, we'll all know exactly what was happening. We'll all know that Kevin just got an email, for example, which is interesting. And it means that we have collectively over the last, say, 20 years, as phones have emerged as the dominant form of computing, created an entire new linguistic set and definition of these small audio cues that we can all recognize, like almost not even as a country or as a subsection of the world, but around the world, which I think is fascinating. When it comes to audio fluency, this is not something that had really occurred to me until recently, how many sounds that we can just instantly recognize that are made by computers. Disadvantages, frankly, you don't know if people are going to hear what you've done. People mute stuff constantly, right? Even if they do leave the sound on, sometimes your headphones will be kind of shitty, or your speakers aren't working properly, or whatever. One else interesting thing about audio, unlike visual, is that it is time-based. If I say, hey, everybody, look over here, and someone misses it, I have to repeat that, unlike if I was holding up a sign that just is sort of statically there in time. Audio can be physically off-putting, if it's annoying, if it's loud, if it's a weird wah, 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 wah. It can be an extremely vague input. I'm talking to you now. It probably would be more efficient if I had written all of this down. It would have taken a lot less time, right? Humans are just not very precise when it comes to how we talk at all. It's slower, again, for the time reasons, and as I kind of mentioned earlier, it's simply not as customizable just because we have certain physical associations with sound that we do not necessarily have with other types of modalities. And then finally, physical modalities. The best example of this that I could think of that it's pure physical is instruments. As a result, instruments have, for the most part, massive physical affordances. Of course, the theremin being the really big exception to that. But when you're really good at an instrument, you don't need almost anything else. You will always get audio feedback for free, but you very rarely need to actually look at the instrument, especially as an input type. Yeah, it's hard to remove the audio feedback, and sometimes it can feel a little bit like it's gone. I actually used to have a GIF of someone pretending to play the piano. How many people have seen the pianist? Amazing, I know. Is that how you say that word? Anyway, okay. In the movie, at some point, he finds a piano, but he can't play it because he's hiding, so he just has his key. He kind of hovers his hands over the keys because he wishes he could play, and you know he knows the melody. He doesn't need to have the audio feedback at that point because he's great. All right, advantages to physical modalities. They can be very, very fast and precise. These are more fast and precise than any other type of input, straight up across the board. There's also less delay between the affordance, by which I mean feeling that you can do a thing and being able to actually do the thing, especially if it's your fingers, because your fingers are super fast. You can also bypass that prefrontal cortex that is so slow and hard to compute and just get it into a flow, right? And finally, it has that strong, this is a real animal brain component. When people say that they want to use their hands in mixed reality, and they do all the time, I'll talk about that in a bit, if you have that haptic feedback, if you have that feel of texture or temperature or whatever it is, obviously, you're just really adding to the whole experience and making it feel real in a way I think all humans want digital things to feel. And it can be subtle. It can just be like a little tweak, a little bump, a little beep, and people will still get it and be able to process it. Disadvantages, obviously, it's tiring. It can be more tiring than any other type of input. And I think this second thing, physical hardware is more expensive to make and more prone to breakage, is actually the primary reason why our phones have turned into gigantic pieces of glass, right? It's just cheaper to make these in the end if it's just one piece and it's not something that has to be maintained. I touch on this in a bit. When I had this slide before, I used to say there was a much higher cognitive load learning physical inputs than other types of inputs. I've since changed my mind about this. I think there is a higher perception that there is a higher cognitive load during the teaching phase, because when someone tries a game controller for the first time, if they've never played it before, they're like, oh, this is confusing. I don't know how it works. Let me go over here to this much more button-filled thing and instantly type away on it. Like there's this assumption that just because you don't know it, it's hard to learn, when in fact we deal with very complicated physical input types all the time. Yeah, and finally, it's a little bit less flexible than visual. I mean, one cool thing about our phones being giant visual displays is that then the buttons can look like anything, take any shape, any form, unlike real buttons. So when do you want to use which one? Depends. It depends on what your users are doing and what you want them to do. At the beginning, when you are describing to people what they need to do, you want to have instructions. When you want to explain to people the problem space, you want to use visual, pretty much across the board, because the information is more dense, and because most people are literate, and iconography is an even more compressed form of literacy. Explain for that information quickly, so use it for your tutorials and onboarding when you need to get people started. Auditoria is good for those visceral reactions when you need people to kind of, in games, know that the bad guy is coming. Suddenly the music changes to a minor key, and you're aware that there's going to be, a dragon coming around the corner. As I mentioned in the surgery context, it's great when users are constrained either visually or physically. So this is why you shout to Siri across the room, "Hey Siri, what time is it?" Because you don't want to have to walk all the way over there, or when you're in your car, right? And great, again, for that ambient confirmation, and we all know what's going on. We all have that shared literacy of what digital tones mean. And then the physical is best for that flow state. In situations where the user shouldn't or can't you look at the UI, again, when you're driving, right? One thing I have to really ding Tesla for is that they have that giant monitor in the middle of their car that you have to look at. Now, I know they're bullish on self-driving cars, but we're not fucking there yet, right? Like, give me some buttons so I can turn up the volume without having to look away from the screen, or from the dashboard. And when you need to be precise persistently for long periods of time, when you need to do time-based things that are repetitive or rhythmic, when you just need to do things super, super fast, you need physical affordances. If you ever really, really watch someone type on their phone, they will mistype almost every other word, literally. But we have autocorrect, and we've also just gotten used to typing shorter emails on our phone. If we want to be precise and type really fast, you really do need a keyboard. It is impossible to have that sort of precision because human proprioception is just not that great without having physical affordances. All right, which leads me into one of my favorite rants, common misconception. I just want to use my hands. I hear this all the time, especially when people are first trying out virtual reality. They're like, "Oh, why do I have to use this controller? I just want to use my hand and just pick it up. It's natural." Okay, that's true. It only took you about 3 years to learn that when you were a kid, but yes, now you have learned it, so it's true. First thing, people use mobile phones as an example of how natural it is to use your hands. If that was true, why do we have to create an entirely new operating system with entirely new affordances and much higher tap targets in order to accommodate our fingers? Answer me that. All right. Second, humans use their hands all the time to control things that are better at whatever it is that we're trying to do. So if you use a pen to write, you're using your hand to control the tool. If I'm typing, I'm using my hands, again, to control a tool that's just better at whatever it is that I'm actually trying to do. One other thing to note, too, is that when it comes to actual object manipulation, we actually use the physical object itself as kind of a support, right? So if I have a gesture like this of carrying a digital cup, this is more tiring than just holding the cup because I can use the pressure of the cup itself as a way of mitigating some of the physical problems, physicality of it, whatever. It's harder to do for long periods of time to go like this. In the same way, it's harder to just hold up your arms for long periods of time. Finally, when it comes especially to our using our hands as input, we are often really vague and unaware of what our hands are doing. So first, again, we're bad at proprioception. If I'm grabbing for my computer, grabbing for my glass, I'll kind of use the haptic feedback of the glass itself. I don't instantly reach out robot-like and grab a glass. If anyone did that without looking, you'd be like, "Whoa, you're a robot," because they would be, because humans are really bad at that. They're also just something we've been sort of trained not to think about as useful for computers. I do think this will change, but if I'm playing a game, if I'm typing on my keyboard, if I am even using my phone, it doesn't really matter where my hands are. My hand can be here, my hands could be here, My hand could be here, or they could be here, it could be behind my back. Doesn't really matter. The computer is getting the input the same way. If you're using gestures, this is actually not true. And when you're using virtual reality and you're moving your hands around and they're fully tracked, this is also not true. I've seen many, many people try virtual reality for the first time, and they always kind of just stand there like this. And you're like, okay, do you see your hand? And they're like, oh, whoa, my hand's here. And they're kind of like, well, now what do I do? And they have to use their hands to manipulate and work with whatever experience they're in, if it's one that has controllers. But it doesn't intuitively occur to them that to do so, because we have trained people that your computers don't actually care about where your hands are. And also, even if you do train people to know that, repeating gestures with enough precision that a computer can recognize it routinely today is not a thing. We're training up machine learning models that are getting better and better at tracking hands. We have a lot of different solutions out there, but being able to repeatedly do the same small gesture over and over and have the computer understand it, as well as pressing a key, there's no computer in the world that can do that today. Or if there is, it's under lock and key, and I have never seen or heard about it. And by computer, I mean machine learning algorithm, not specifically a computer. I mentioned this a little bit earlier. There's this assumption that gestures are physical input, that they're the same as typing on a keyboard. That is not true to the computer. Gestures are visual. You need a camera facing you or tracking your hands, facing the hands in order to track gestures. So to the computer, they are a visual input. Game controllers are hard to use. Hear this one a lot too, especially with virtual reality. From my experience, most people can pick up and start using a game controller pretty fast. I say a couple of hours here to be nice, like if you want to go play Street Fighter, whatever. But if you just want to play Tilt Brush, most people get it within about 2 to 3 minutes, at least the basic mappings, right? I once had someone say to me, I want to use virtual reality as intuitively as writing with a pen and paper. I'm like, man, dude, it took you like 8 years to learn how to write with a pen. You had to practice every day. You had to go to school and have someone teach you how to do this. I don't think you want that. All right, more common misconceptions. This one comes up a lot for mobile, where they say, oh, it's so intuitive, child picked it up right away. They instantly got that you do this. Children can learn any fucking thing. That's what they're designed to do. So if a kid learned it, you do not get to brag about it. Now, if your 80-year-old grandma picked it up right away and instantly knew what to do, congratulations, you win a prize. That's great. Another thing you hear a lot canonically is them saying like, oh, my, swiping is so intuitive. My child tried to swipe the TV. Okay, your child has learned that swiping does things. If you find a kid from the 70s that was swiping their TV back then I will agree with you that this is a common human intuition, and I will take the slide out of my talk. And finally, visuals are more intuitive. No, again, like we have to go to school to learn all this stuff. Like it's what is intuitive? I don't know. Like wanting to eat and cry, that's about all you get for free. Everything else is taught. This also brings us, these aren't so much misconceptions, it's just really strange mysteries that I've seen in my time with mixed and augmented reality. This is intuitively true, I guess, if you think about it. We're just a bunch of sensory inputs, and then we process it, and then we kind of react to it. So the way we see the world and deal with the world isn't necessarily the way we want the world to be. And so when we go into spaces where there's non-Earth physics, where I could just pick up this stool, and I can do this in VR, right? Just pick up the stool, move it here, and just have it stay there. I'm like, cool, that actually feels good. In a way, this actually feels more satisfying than if it just dropped back down to Earth. I feel like I have more control, a little bit more God mode. And I have no explanation for this whatsoever. I just think it's an interesting thing that I've seen time and time again. People are okay living in a world that kind of has gravity, but kind of doesn't have gravity. Humans have a God complex. How many of you have tried a really boring virtual reality experience? Yeah, a lot of you. I'm sorry. I don't know why it was boring. I'm sure there were a variety of reasons, but one of my top reasons is usually when I can't do anything in the experience. I'm just sitting there like, no, that didn't work. Nothing's happening. Okay, I guess I would just stand here and watch this for 10 minutes. Thanks, this is really boring, right? Humans like to have the world react to us. You see a lot of multimedia experiences where you've got a Kinect facing you and there's a giant wall and you can interact with it. We love that. But I don't know why, because we don't get that in nature. but yet we love it with the digital. Again, it's a mystery. And then final mystery, maybe not so much of a mystery as just a point. Humans really ignore how much they mess up constantly, and therefore they sort of overvalue things that they do routinely, even if they commonly mess up because they're used to doing them. Again, typing on an iPhone is a classic example here. But people are constantly doing things like not picking up the cup or missing it a little bit, and yet everyone thinks that they're perfectly fine and normal and good and great at picking up cups. No one's good at picking up a cup. It's weird. Since I'm talking about inputs and outputs, the modality, I want to mention a subset of inputs that are not modalities. They're just inputs, the passive inputs. And these are the ones that are kind of new, kind of weird, kind of interesting, a little creepy perhaps. And the big difference between these and the other kinds of modalities is they work best if you're not aware of them. You don't want people to be thinking about them too much because that will mess up the data. So for example, if you're trying to measure things like unconscious limb movement, or object movement, or voice tone, or eye movement, or heart rate, you actually don't want people thinking about this too much because you're trying to figure out what's really happening with the person. And if they know that their breath is being measured, then of course you start thinking about breathing. Now we're all going to be thinking about breathing for the next 10 seconds, and we're all going to start breathing weird. That's what happens. So you see why I say it's better if these are unconscious. And as conscious inputs, I've done a couple of examples of using my eyes for selection or controlling things with my breath. And I can tell you, it's an interesting exercise for like 10 seconds, and then you're like, no, I don't want to have to do this anymore. I don't want to have to think about where my eyes are precisely and then have to move them. Eyes aren't designed to work that way at all. Okay, I bring this all up because I have seen a lot of experiences that didn't take into account these modalities and use them correctly. I've seen many, many, many. This happens all the time with all sorts of digital things, but it is much, much worse when it comes to mixed reality and virtual reality because the more off things are, the more incorrectly applied these modalities are, the worse the experience is. So I've come up with this little loop, this little graph, the affordance discovery area, the action area, and then the feedback area. And this is basically how you and the computer talk to each other all day long in any capacity, no matter what computer it is. So I've done a quick mapping of this to a conventional game controller, right? Okay, so for most games, you got your visual in pink, and most of the time the game will kind of tell you, either with words or later on with visuals, like, you know, there's a monster coming, you need to do something, and maybe there'll be some audio as well, some sound associated with it. With a game controller, specifically, there's only one kind of input that you've got, which is a button press, and that's entirely physical. So you press the button, the B button, and then you swing the sword or whatever it is you're going to do. And the feedback will be you see the sword swinging, you hear the sword swinging, and maybe there's a little bit of haptic feedback from the controller. And this is it. This is super simple. And again, I want to bring this up. I think a lot of people do this unconsciously. I think the best designers and the best app makers and the best engineers just sort of will do this by default, but they don't do it systemically. And again, when it comes to virtual reality and mixed reality, if you're missing this in any capacity, it feels less real, and your experience is therefore not as good as a result. There is a trend right now towards intuitive design that requires simplicity. If it's simple, if it's intuitive, I don't need to teach people. They should just understand it from the get-go. I've even played some very confusing games that didn't have any sort of onboarding at all. The gameplay itself was designed to teach me this. This is honestly a bit egotistical first because it ignores the fact that we've all been learning how to use these phones and game consoles and computers for years. So they're just building on top of an already pre-existing structure. But it's also just not necessarily true. This is from Red Dead Redemption. This is the highest ranked game of last year and one of the best-selling ones of last year. This is just like a normal screen. I found some screenshots, and it tells you exactly what buttons to press and what they look like over here. And then down here, it tells you everything that you can do, right? And this is on what is otherwise a minimalist screen. It's being incredibly clear. Here, I'm not sure if everyone can see this. Again, it tells you exactly where every single button is, which one to press, what they look like, and what their names are. And this is when you're halfway through the game. It's still telling you how to play the game and what you can do in the game. And finally here, I'll zoom in on this one a little bit. This, again, is just on a conventional screen. And the reason why we need to have this much visual affordances at this stage in the game is because you're constantly switching what it is possible for the character to do, and you're remapping the buttons constantly as well. So R2 is aim weapon here, because now you're in weapon firing mode. But if you were in, horseback riding mode, or if you're in the store, then you have to remap the button to something else. And this is why you need this constant visual affordances. So don't go into maybe you don't do this anyway, but that's great. Don't fall into the trap of feeling like things need to be simple in order to be correct. You can have really compelling, complicated, interesting, full world system experiences. Just use the affordances and the input-outputs modalities correctly. This is another big thing that ties back into the modalities, and my team actively uses this spreadsheet for all of the different things that we do and make. So for every state that you have for any given object, and it could be a piece of UI, it could be a thing that's going to be acted on, it could be a character, it could be whatever. You have all of these different states. If you've ever done like web design before or anything else, you know about pseudo classes and different state information. But when it comes, especially to virtual reality, you actually have a lot more options of intent because you have a whole other dimension to work with. So for example, here's this chair. I could select this chair. The default state is, no highlight. But then if I hover over it with, say, like a ray, then it goes into highlight mode. But it's not active yet, right? I haven't selected it. So when it's inactive, then it goes in that mode. Maybe there's a mode where when I'm getting closer to it and about to make it active, as the trigger is partially hit, it goes into another type of highlight. Confirmation that it is activated might not be the same as active state, depending on the object. After it's activated, say after it's been moved, maybe you had a ghost that actually does the movement, and then the object has to actually move to match that object. And is stable state. What does it look like when you can't do anything? So again, I'll make this available. You can download it. A lot of people who are the best types of thinkers do this stuff unconsciously, but not everyone does. And I think this is also a great tool to train up juniors about how to start thinking effectively about all of the different ways an object can look and feel when it's being interacted with. Does anyone have any questions so far? Yeah. I think we need a microphone. Got a mic?
Hi, my name is Francisco. I'm sorry I don't speak very well English. I hope you can understand.
Mm-hmm.
From the other kind of inputs that you say in the talk, do you know some experience with EEG, brain signals?
Yeah.
What is your opinion about combining this kind of biosignals with virtual reality?
So I have tried several different BCI input types. There's electrical brain information that you can measure. There's also neuron firing that you can wear and have that measured as well. The ones that I've tried that are on the market today, or sort of on the market, if you've got $30K to spend, tend to only be able to measure a certain number of states. So for example, Neurable can measure intent and then selection, but it cannot measure maintain selection. So in order to work, their demos have to say once it's selected, it has to stay selected. So I can't, with my brain, say, keep picking up the cup and now put down the cup. I can just say, cup. And then whatever else happens with the cup. That's supposed to happen. That's incredibly limiting, right? It's like being able to only click once. I think we'll be able to do more with this. But I actually tried another demo. I won't mention the manufacturer, but I will mention what the thing that surprised me about it. So this particular manufacturer measures neuron fires in the arm. And I tried a couple of experiences that were what you'd expect. You could kind of pick up stuff and grab it and move it. Very cool. Felt like Yoda. And then they wanted me to try an experience where I made my hand movements smaller and smaller and tried to play just a quick jumping game by thinking about jumping as opposed to actually moving my fingers to jump. I trained up customize it for a little bit. My hand movements got smaller and smaller, and then at some point, it was just supposed to think jump, and it would jump. What happened was, as I was thinking, don't jump, don't jump, don't jump, jump, and my brain was like, zhur, 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 zhur. And so the thing on the screen was like, and that was when it occurred to me that In order to be able to use these effectively, at least in the short term, we're going to have to do some kung fu level of mind control, where you're like, do not think jump. Don't think jump. Now think jump, right? I mean, when I think about mind control, I don't usually think about it like that. And yet that's the reality of where we are today. So I think it's a cool idea. I think it's not going to be as obvious as we think it is. Like, I don't think it's going to be a panacea solution for sure. So anyway, that's a long story, but you get the idea, right? Okay, so the reason why I went over the modality stuff, some of which may seem really obvious or easy or simple or whatever, and if for that I apologize, is just because as humans and computers start to behave more similarly, there is a larger chance of there being this uncanny valley. And particularly when it comes to XR, you need to have well-designed experiences because we are really entering in a new reality, one that has some physical elements and one that maybe doesn't. You know, it's sort of like entering into Harry Potter world. Gravity works sometimes. Sometimes you can just have stuff come to you. Sometimes you get to fly in a broom. What is the system there? We don't know. But in order to make sure that people feel like they understand whatever system it is that you've chosen to make, we need to have these modalities consistently in place. I think when it comes to uncanny valleys, we're all pretty familiar with stuff like this, right? Everyone is aware that this is creepy as hell and never should have been made. I'm just kidding. I know a lot of time and work went into this. It's going to get better. But there's also uncanny stuff like this. Oh. There we go. How many people have seen this? This is Tesla's automated fuel injection thing. That's bad. But there's also uncanny things like this. We don't think of this as the uncanny valley, and yet this is the uncanny valley. This is a computer being super stupid under the pretense of being human-ish, right? Maybe it isn't as viscerally negative as the other ones, but it still is. This is uncanny as well. I'm just mentioning that because I think that we can extend out this uncanny valley metaphor quite a bit more than we already have to all of these different types. When you're talking to your assistant, and they act, your home assistant, Siri or Alexa, or whatever it is, think about the fact that they're not responding to you, not so much that they're stupid, but as they are existing in that sort of quasi-humanistic land. On the flip side, there's some advantages to the uncanniness or this sort of alternate realityness that are fairly obvious. I always like this example. This is from the Medium tutorial because it shows kind of what people are, how people I think are sort of mapping the reality against the in this case, virtual reality. So you've got the actual controllers, which look like something, and then you can have the physical controllers still kind of match up, or sorry, the digital controllers kind of match up, but still be their own thing. So that's a nice version of the uncanny valley becoming the canny valley at some points. But on the flip side, the reality tends to be more like this. This is a test someone did with a Magic Leap controller where, as you can see, it's not really tracked one-to-one whatsoever. It's off by about 3 inches. And this can be a pretty big disadvantage if you're trying to have someone select something and they don't realize the reason it's not selecting is because the computer thinks it's 3 inches to the left. This is much more of a common thing. Again, that uncanny valley, it extends to more than just, creepy robots. So computers will always, they're learning, they're continuing to learn. We will eventually have self-driving cars level 5, but humans will always stay pretty blissfully unaware of why things aren't working. And again, that's why we need these modality loops to make sure things feel real, feel firm, people understand what's going on continually. So here's some examples of modalities in action. This is great. This is Project Create by Magic Leap, and it's pretty game-like, but it's got wonderful visual affordances, it has great animations, it has great sound design. It is a wonderful little gem of all the modalities in motion all the time, just having great haptic feedback as well. I couldn't show you that. But I highly recommend, if you haven't tried this, it's probably one of the best in-class mixed reality experiences today, and it really goes through that flow just beautifully. A lot of people who worked on this were game designers before. This is another example of, this is more, a little bit outside the modalities. These are more examples of just good design. So this is Oculus Medium. And you can see here that the user has a laser pointer that comes up whenever the menu comes up. And this is cool because it tells you 2 things. It tells you that you have switched away from sculpting, which is the primary action that you do in Medium. It's a sculpting tool, to the UI, And it's a pretty subtle change on the controller itself, but it shows you now you're doing something else entirely. The other thing I love about this is that the laser just maps directly to the UI regardless of where the angle of the hand actually is, which means you can be like this and it'll still point where you want to. So in that sense, the ray here is actually angle agnostic, which is great and means it's just less tiring to use, less repetitive. All right, here's another interesting example of a cool interface. That's the radial menu. So the radial menu is neat. We actually use it for the tools that I make as well. How many people have tried Create, by the way? Nobody? Okay, it's great. To date, the only creation tool for virtual reality I know that is actually used in production. The 3D models that people make with this are actual production quality models and can be used in AAA experiences. So I recommend you try it out. Whether or not you're a good sculptor, it's definitely worth it. But the cool thing about the radial menu, the reason why I brought it up there, is because you see she's pointing at it to select objects here, but you don't necessarily need to. You can also just use the joystick. So it's an agnostic type of interface that works with on either hand, depending on what you want to do with it, because you have the joystick on the left hand. This is from Gravity Sketch. One nice thing about this Gravity Sketch, which is a sort of a professional grade drawing tool, you see here that they're trying to select an object that you can't actually select. And so when you try to do so, there's a little warning that comes up to tell you that you can't select the object at that time. Here's another example from Gravity Sketch. And this is an example of a menu that is pinned to the controller, but then can be pulled off the controller and pulled into space. If you do make menus that need to be persistent in virtual reality, I highly recommend you pick up this paradigm because you never know where the user is actually going to be and how constrained their movement is and where they will actually need to be able to put the UI. One other thing I wanted to note here too is you see that these are for the touch controllers. That's the Oculus Touch controller model right there. But then in this example, this one is with the Microsoft Mixed Reality controllers. And they've actually done a pretty good job of mapping it. So the model looks the same, and the action affordances is fairly similar, but they switch out the model depending on what controllers you're using. Getting into best practices for virtual reality, I highly recommend that you use the controller models instead of hands. You can also use the hands if you need to, or if you want to, or if you feel like it makes the experience more visceral. But unless you're playing a sort of fully immersive game with an FPS where you want to have guns, for example, instead of controllers, the best thing to do is to have people be able to see what's actually in the world with them. That way they won't run into stuff accidentally. That way they'll have a sense of looking down at their hands and being able to double check themselves until they've memorized the button labels and so on. And here's another example. I really like this. Tavori is an animation tool for VR. And one thing I really like about them is I think they've nailed the whole, if I pick up something and move it from here to here, I should be able to animate it, you know, just like toys as a child. And they've done an excellent job of taking this to the next level. They also have great selection states here. So it's pretty subtle and fast, but you can see they have a hover state, an action state, and an about to be hovered and acted on state as well. So they really nailed the whole, that big object states grid. They have almost all of them for all of this. And the reason why this is so important, especially for creation tools, is because you might have multiple objects and multiple levels of state selection at one time. So you might have objects on a layer that is selected or deselected or disabled, and then within that you might have a group, and within that subgroup you might have the object that is the most selected object. I tend to focus on creation tools because I make creation tools, but they are also some of the most complicated tools available for virtual reality today, so that's why I like to talk about them. I have an example of bad design that I will show you, but it's from my team, so I don't feel bad about it. So we made a little wireframe tool, and I have an example of good design from us too, but we made this wireframe tool for Magic Leap because we realized that it's very hard for humans to estimate the actual size of the field of view for these AR headsets, and it's better to actually just be in the headset drawing it out. But we kind of came up with this, what we thought was a very elegant but very mystery-meat interface and UI. So don't do what we did. Don't make people hover to figure out what it is that they're trying to do. How many people have tried a Magic Leap or HoloLens? A couple. Okay, not that many. For those of you who have not, the limited field of view on the AR head-mounted displays is by far the biggest challenge, design issue. It means that you, for one section of the visual field can see into this world and interact with anything in that world. But if you were to take anything out of that field of view, you can't see it at all. It is completely gone. Humans aren't used to thinking like this. It's like wearing binoculars or even just looking through, you know, when you're a kid, you look through the paper towel holder thing, right? Yeah. So that is a huge design challenge to work around, which is why I highly recommend, if you're going to make UI for it, be in the headset actually doing it at the same time. This doesn't look so great in this GIF, but we realized that when you actually have a selected state here, you didn't actually want to hide what was behind it because the UI is so large. So instead what we did is made the whole thing semi-transparent, and when you pick it up, it actually gets more transparent. So it's sort of, as you're moving stuff around, when it's in your field of view and you're more likely to be looking at it because it's moving, and humans are attracted to moving objects, we actually make it less visible to make up for that. Otherwise, it would feel really overwhelming to be moving around these sort of meter-wide objects all the time. For virtual reality, too, there's also a bunch of different locomotion types, almost all of which we've put in our own tools for various reasons. So you can fly like this. This works for some people. It can make other people sick. You definitely don't want to change the camera angle if you have people fly. We also have the ability to just grab the world and move it around it like so. You can go fast if you don't get sick. Let's see. You can also scale the world. And you can also grab the world and just sort of move around it kind of monkey style. So these are all just different types of locomotion that you can have in virtual reality. And again, we decided to include them all in the tools that we made because we don't know where you are, and we don't know the size of the game or experience you're trying to make. And then we also have this blink locomotion, which is a standard for a lot of virtual reality games. But we wanted to just make sure if you're standing at your desk, or if you're like sitting in a little cubicle, or if you have 20 feet of space, whatever, you can move around the virtual space any way that you want to. Depending on the type of experience that you're making, you'll probably only want to choose one or two of these, but this is a nice showcase of basically all the different ones that are standard and available today. This is from Microsoft. This is a great example of having a bunch of different objects and being able to quickly select and work with them. So you see here that someone's making objects and then able to just quickly swipe to auto group and then be able to clone from there. Wow, you really can't see this at all. I apologize. Oh, okay, it's a little bit better here. So this is from a game called Starseed. And this is an example of an in-game tutorial, and this specific tutorial actually comes up when you hover over an object that is selectable, which is highlighted. So again, this is just an example of the object states that I was talking about earlier. And this is an example of good design for the AR HMD, what I mentioned earlier about the field of view. So we had a menu that is attached to the controller, and when the controller is in the field of view, it will populate based on where it is. So it'll always show up inside the field of view. So this is showing a test. The field of view is only like this. So no matter where you are, it'll show up there. And then if you move your controller out of the field of view, it actually will just show up in the middle of the screen. So it follows the controller around as it goes around the field of view as much as it possibly can to try to stay in that line of visible sight as much as it can. And when it has no chance, it'll just show up displayed in the middle of the screen like so. Do people get this? I feel like this one's a little hard to understand unless you've tried the HoloLens or Magic Leap. Okay. And finally, I want to, not finally, but almost finally, I want to do a deep dive specifically into selection. I've talked about this quite a bit, but I want to talk a little bit about the systems behind it. So really, when it comes down to it, there are two ways to select anything at all. But specifically for virtual reality and mixed reality, these are the big ones. First, you can directly select it. And this is how you pick up stuff in real life. I am directly picking up this object. Actually, interesting. This is kind of direct selection. That's funny. Because when I'm in VR, I could actually put my hand in the object and actually pick it up. And it is literally just mapped to the controller. And you can have it directly move, so it's mapping one-to-one, or you can have it kind of constrained, like it'll move around with your hand one-to-one, but it will be constrained by rotation. Like you can never move it on a certain plane or a certain axis. And then you can select objects at a distance. We call this ray selection because a ray comes out of your controller, and then you can pick up, you're right there. I could pick you up and move you, for example. And there's two ways to do that. You can use direct selection again. or it can be constrained. You can also use head direction pose if you want to have people gaze at something to select it. This is really tiring. I would only use this if you absolutely have to. The reason why it's a really bad idea to have direct ray selection is because rays are levers, and so if I have a ray coming out here and I were to try to pick up that stand one-to-one, it would be going wildly all over the place, right? Because if I move my hand 2 degrees, by the time it gets to this podium, it's 30 degrees, right? So everything is just exponentially more difficult to control the further away you get. So these are the types of constraints. A lot of these we had to put into place for our tool sets as well. When we first started doing work on selecting objects at a large distance, we had an example of a mountain that was like half a kilometer away. And you just picked up the mountain and you'd move your hand like ever so slightly, and you'd move it like 10 kilometers, because by the time the ray hit it, it had gotten so much further. So that's how we found out that we needed to do things like this. Have a limited distance that you can move an object. So now we limit it. You can't move an object more than, I think, 100 meters, honestly. We had to have a lot of ease and tolerance. The further away the object is, the more it doesn't count if your hand moves. We have to have larger hit targets for small objects and for large objects that are at a distance. We did do some work around trying to have selection UI look the same at any size, because that's the way we have it in Unity today. No matter how zoomed in or out you are, the selection gizmo is always the same size. It turns out if you do that in virtual reality, you feel like you're on drugs, and that something is really wrong with the world, because when it doesn't move and everything else is moving, it feels like this weird break in the universe that something has gone phenomenally wrong. So try it for fun. Don't actually put it in your products. Lazy follow, we had to do this a lot, especially for Ray. You want to make sure that things kind of, if I'm picking up something, it should sort of gracefully follow me. It should, if it's too direct, it feels too forced, and it's actually less precise than it would be otherwise. For things like 3DOF controllers, for sort of semi-tracked hitsets like the Daydream, they also have wavy sort of rays. And the reason for that is just to kind of hide the fact that it's not fully tracked. It's not actually one-to-one, but it's useful for all types of experiences. In constraints emulating physics, one of the big ones that you'll find is when you can move anything anywhere you want to, because you're in the computer and you can do whatever you want, is that you'll always do it wrong. Because in the real world, we have physical constraints. If I want to put this water bottle on this table and have it at a nice 90-degree angle to the table, this is very easy to do in real life and physically impossible for humans to do precisely in virtual reality. So we need to do things like fake colliders, fake physics, fake gravity, in order to have you be able to make out things that look realistic, honestly. So that's why snapping to planes, snapping an axis, and snapping to faces. So for example, if I wanted to have this move along here and rotate on the side, maybe I want it to rotate like this, or maybe I want it to rotate like this. We have to give users the option to do all of these. Yeah, and finally, limited rotation again. If people are moving too quickly, just flat out ignore it. Often if things are moving super quickly, that actually just means that tracking has been lost, so just ignore any of that type of data. For mobile AR, stuff is a lot more limited, and there's also a lot of language already around how to select objects. So you can have direct selection, which is just, pointing at something and moving it around. I think this is the way most of us have used any type of 3D stickers in augmented reality. You can move stuff at a distance, so if it's a bit further away, you're still kind of moving it around on the screen, but it looks like it's about 5 feet back or so. We did some experiments around moving the controller as a stand-in for an object, and this is useful if you have to move something far away. Mobile AR is not that great right now. There's a lot of drift, but if, for example, I wanted to pretend that this chair needs to be moved over here, it actually might be more efficient for me to just be like, okay, the controller, there's now the chair, tap it, it's here now, right? So that, and therefore the phone becomes the controller which stands in for the chair, and the chair gets placed there. Does that make sense? Yeah, okay. A lot of the swipe or scale gestures have become kind of a rotate gesture, something that we've noticed across the board for mobile AR experiences now. Two things I'll note, I'll have some examples of this as well. When you're making mobile AR, the controller is the display, which is kind of the sucky thing about it and also the great thing about it. So if you have something that you have selected and you push it further away or move it closer to you, the further it is away, the smaller it gets, the more likely it is your finger is just covering it up. So gizmos and other types of affordances around the object are the best way to make sure that people still know the object is selected or being moved. So this is, for example, IKEA. You're moving furniture around. You see that they have gizmos and rotation underneath the object itself. And the objects are large enough here that your finger couldn't cover it up in any case. Another example. One thing, too, is that because on mobile AR, you're just looking at the camera feed, you're not really looking at the real world, it's pretty easy to get a little bit lost about where the floor really is. So gizmos like that are helpful. And then finally, for Torch here, you see that they have a two-handed gesture that would normally be for scale in a conventional, like pinch to zoom, but here is being used for rotation instead. This is actually one of the designers on my team, Bushra's slide, which I borrowed for this talk. And she has some nice examples here of moving static images around in 3D space versus rotating them in space as if they were objects pinned to the space. This is an example of some early work we did around constraining to ground and moving around gizmos. So you would move around an object on this small thing. I have other examples later on. We called this the chessboard at the time. And then you could see the object being moved in space. And this was our way of trying to get around selecting large objects and having them move too far or not in the direction you wanted them to go. If we just put a little version of the world in front of you that you could move around just using forearm movement instead, you tend to be a lot more precise. Here's another example. Snapping to bounds, in this case. You're moving an object and you want it to be able to, in this case, kind of be moved all around the space, so it keeps snapping to the top of whatever object it is that it's currently next to. Which one is this? Oh, snapping limits. All these are so much darker than I thought. One thing we realized when we start to do snapping is that you need to have different constraints for where you are in the snapping point. So if I snap to this table, it kind of snaps about, I think we calculated the distance to be something like 1/5 the size of the model object. And once it gets close enough, it'll snap. When you want it to snap away, you have to pull farther. So the snap point is about here, up here, but when you want it to snap off, we force you to pull it down a little bit more. We realize the reason is this: if the snap point, the anchor point, and the snap off point were about the same, people would snap off far too quickly. So here's another example of the miniature world, which now we call it a mini world. One cool thing here is that you're in the space here, you're actively in the space, making your experience, and then you have a smaller version of the space here, and you can move yourself around. That's actually you, so it's another way of moving yourself using our tools. But then you can also have another version of it over here. So you can have these 3 different versions of the world at the same time, and you can have, say, one part of the city, pick up a tree, either move it to the other miniature world or actually pull it out and pull it next to you. And this way, every object in the scene is easy to find, it's easy to manipulate at any scale, and it's easy to move anywhere you want to. And it also is just really kind of fun because it's a total mindfuck to be like in the world 3 different ways at different times. For a while, we actually showed you the hand controller, so you could see you picking yourself up. So you would see this giant hand in the sky come down as you bent down to pick yourself up. It was fun. So I went through all of these different types of selection because I wanted to just show what's possible, what we have done already, get you thinking about this a little bit more. And the reason why I wanted to talk through these specifically is because I think, again, we have this sense of how we should be able to select objects really easily that comes from cinema. So this is always the classic example I use. But as you watch this video of Yoda fighting Emperor Palpatine in the Senate room, I want you to think about how I showed you really have to select objects, how you really have to think about ease and affordances and rotation, not to mention having to switch between single select and multi-select and all the other stuff. So here we got Yoda and Palpatine fighting each other. I'll go off the screen so you can kind of watch it. So the Emperor's multi-selecting here. And I think he's going to go to single select soon. Yep, single select now. And now Yoda's going to go into catch mode. And now he's going to go into rotation mode. and they laugh. And now he's gonna kind of switch from rotation back to selection and throw without changing any movement whatsoever. The Force OS is way more robust than any OS we have today. Anyway, I just wanted to show you that because I think that's how we all think. Like, oh, I just pick up this object and then I'll move it and I'll put it over there and I'll kind of magically go where I want it to go. It's not how computers work. We have to think through this a lot more. Finally, I just want to briefly talk about the future of the fun stuff. I'm working on a new project called Project Mars that is designed to take as much of this information we're getting from cameras and sensors as we possibly can and put it back into Unity. So we have new views like this. Looks like just a kind of standard conventional little living room. The reason why it's special is that Unity thinks this is a real living room. There's no difference to Unity between this being an actual real living room, a mesh of a living room, a CAD file of a living room, or a bunch of models that look like a living room. We have created a new type of component for Unity called the real world concept, and Unity then will just treat this like another piece of real information. If I move this chair in real life and a camera sees it and that feeds into Unity, that will be the same thing to Unity as if you move that model in the scene view. And that's one step towards building and authoring against the real world. We also come up with this concept called fuzzy authoring that allows you to lay out things more flexibly than you would, because in the real world, stuff moves constantly. So again, if I had this stool, if I'm making a game today, I would have like an animation sequence where you would come up here and sit on this stool, right? That's pretty simple. You can do that today. But what if I move the stool over here, right? Your animation cycle still goes only here, so you're going to be hovering, off the chair. If we use the tools that we have here, we allow you to kind of say, find kind of roughly a chair in a space roughly around here, and if it's this big and it's this high, then perform the action and have the character just go to there. The fuzzy authoring stuff, we call those conditions. Any given condition, find a stool, find something that's off the ground, find a dog that's a high enough size, use that at the chair you want to. And then we have ways to test out different environments to see if your experience will work in this room, will it work in this room, will it work in this room, and if it didn't work, why didn't it work? So these are all the new types of ways that we're trying to figure out how to take in all of that, again, sensor information, and let developers do something very quickly with it. So we've created, as I mentioned, this whole new idea of something that isn't real and never will be real, but it is a match for a description of something that is real. The real world context. So it's a context around something that will exist in the real world. We allow you to create relationships between them. So when you find this stool and you find this podium, then put a castle on the podium and a bridge on the stool, right? And then Replicators allows you to say, like, when you see anyone's face, put a stormtrooper helmet on it. Sweet, now we're in Star Wars. And then finally, we allow you to take in synthetic content and author directly against that, like the models that I was showing you earlier. I have a lot more I can talk about this. It's not really the point of today's discussion. I'm happy to talk about this more offline as well. But the key of it is that we're going to have to tell computers things that we have never normally told them before or had to articulate or think about at all. There's a whole bunch of stuff around how we work in the real world that will need to be sort of codified and standardized across the board. What do I do? What do I see when I walk into someone else's house? If I'm wearing glasses and they have cool art on the walls, if they have cool digital experiences, if they're watching Netflix on their glasses and they want me to watch Netflix with them, right? So we've been thinking about this quite a bit, and I've given entire other talks just specifically on this. But I just wanted to give you a taste. These are the type of things that we're thinking about right now. Example of spatial permissions. When I walk into Kevin's house, do I get to see his cool digital art or not? How do we define that? How does he define who gets to see what? Social permissions. Are we close friends? Are we part of the public? Do we see street art right here? Application states. Is something on or off? Is it an event triggered by time of year? Do we all see digital fireworks New Year's Eve? Location states. Where are we now? Am I close enough? When do I start to see an ad or not? UI types, is this something I can control, I can move, or someone else can control and move? And then trajectories, where is this object? Is it moving in space? Is it tied to my HMD and it follows me around? Or is it tied to a building, et cetera, et cetera? I'm going through this very quickly. Again, I'm happy to talk about this at length. That's super fascinating. But we are really almost at time, and I do want to take any questions you might have, so I'll just say thank you very much. Appreciate it. All right, Thoughts, questions, arguments?
In your experience, what do you think the best way is to prototype applications you're building for VR and AR?
The best way,
Yeah, like what's
straight
a
up,
sketch equivalent?
I would use Google Blocks, Tilt Brush, Tavori, the animation app that I showed. Not to toot our own horn, but Editor XR, our own open source tool, lets you be in virtual reality and lay out your entire game. So yeah, be in the medium. I think that is the #1 key. And there are a lot of tools out there that people have built for themselves, like Quill, actually came from an experience. Dear Angelica, Inigo Mendez, I think is his last name, actually made this just as a tool for the artist who was making the piece, and they've actually released it, and it's on the Oculus store. You can download it for free. So be in the medium, use the medium. Because otherwise, by the way, you're always wrong. You'll be like, yeah, this will work, and you get into VR, and you're like, it didn't work. Any other questions?
To me, the most awkward thing to deal with sometimes as you get into AR and XR is how you interact with people that aren't sharing that same
I know.
digital experience.
I
where
agree.
you're like, you just walked through my thing, fuck you.
Yeah.
Or like you don't have that room to do a gesture around somebody that's not
Yeah.
in it. Are there thoughts that you have
Yeah.
on?
Network everything by default. Yeah. Make all your experiences multiplayer. Yeah, I agree with you, especially mixed reality. It's the worst. At least in virtual reality, people can watch on a screen, right? At least if it's not a standalone headset, people can kind of experience it alongside you. And we've actually done some experimental work around using mobile phones as kind of this window into what other people are seeing or doing. It has some serious limitations because then you have to make sure that the experience app is not only networked, but can be run on a mobile device, which means smaller file size, smaller game size. The models are worse, it has to be mobile compliant basically, or mobile performant. That being said, especially in mixed reality, as I was saying, it is so annoying to be like, there's a Porg right there in the Star Wars experience for Magic Leap in my living room and you can't see it. Because it feels like it's there, and yet the fact that other people can't see it means it's evidence that it's not there. Actually, one of the most magical moments I had was playing the multiplayer Dr. G experience at GDC this year, where you're like shooting each other with lasers and you're all in the same space together. So I don't know if I have thoughts around that other than, yes, it must happen, and the sooner the better. And things like the spatial anchors and the cloud anchors from Microsoft and Google are attempts to move in that direction. And Apple also has object persistence as well. It's a big problem, though, for a lot of reasons.
Thank you for the talk. It was fantastic. I'm doing a lot of research at the moment as a narrative and story designer into the use of different textual and non-textual experiences in VR and AR. And I haven't been able to find any really interesting or compelling uses of text yet.
Right.
And I'm wondering, well, maybe you have some recommendations, or what are your experiences as a designer with using text in a VR AR experience?
It has the limitations of the visual, which is that you must look at it. It can stay there forever. Another actual limitation is that VR headsets are not very high resolution, so the text must be large, right? I have seen it used in a painterly way, almost as sort of like graphic design. There was an experience I saw a couple of years ago at SIGGRAPH where someone was kind of talking through a breakup, and it was this visual experience with like the words, I love you, I don't love you, love, yada, yada, yada. And it was kind of akin to a projection mapping. I would say it's probably the closest equivalent. And that worked really, really nicely and played with this virtual space that would kind of open and surprise you and had dimensions you weren't expecting behind it. So I guess to extract out from that particular piece, I would say that since text is inherently 2D, use it as a two-dimensional gateway to whatever else you want to do in the space, right? Yeah.
That sounds great. Thank you.
Sure. Yeah.
In human-computer interaction, the usability is very important, but there are another concept that is accessibility that normally the people don't apply in virtual reality games. In Unity, I'm an expert user in Unity. Do you have some plugins for apply accessibility tools in order to guarantee that the game or application is accessible for people?
Yes. There is I don't think it's not an official Unity kit. There is, on the asset store, I just recently saw specifically something that would translate object meta information to text. But as I mentioned earlier, when it comes to disability, I mean, we actually have a use case that it's a friend of one of our designers. He is blind in one eye, and he only has use of one arm. He likes virtual reality because it's easier for him to see, and he can actually see depth in a way that he can't see in the real world. So when we design experiences, we often keep him in mind, like, can you do everything with one hand, with one controller? And sometimes we find that if we make everything one controller, like scale, if you're just doing that with one hand, it would inconvenience most people. Therefore, it should be a mode that you can go into. But when it comes to thinking about disability, some are too specific to make everything accessible by default. So we try to have very specific use cases and say, does this make sense? If so, let's just stick it in there by default. Otherwise, let's make it a mode. Yeah, it's hard.
I think one of the challenges I've had with using like VR headsets is typing.
Oh yeah.
What's the best keyboard that you've seen for these kind of systems, and like how do you think that will be changed in the future?
Logitech has a track keyboard that has a model in, so you can put it in your experience. That's the best one. I think that's also the only one. People have tried to make, actually, oh shoot, I can't remember his name. He's a dynamic now. Luke Inari, I think, made a pretty cool, he broke apart a keyboard and used a touch controller to kind of type. Max Weisel of Normal VR made a scalable keyboard that you type on like a drum. We actually used it for some of our own work. So if the keyboard was at this angle, you would type on it like a drum. And when you turned it like this at a 90-degree angle, it would switch so that you click to type. Because we found that when you're typing alphabet, you want this more. But when you're trying to be very precise and you know exactly what you want to type, like 3 numbers, it's actually easier to do it with a click. Yeah. Just depends.
A bit to follow up on that, I'm lazy.
Yeah, me
and
too.
I like to sit down all the time.
Yeah.
That's one of the things that I noticed when using VR.
Mm-hmm.
I stop using it because you get tired
Mm-hmm.
and too many arm movements.
Mm-hmm.
Is that
Yeah.
an evolution? Is there an evolution there in design?
Yes, I think so. It depends on the experience, of course. If you're doing a sword fighting game, you're going to move more. And I have a philosophical argument with this about one of the designers. He's like, people are lazy, they don't want to stand up. I'm like, well, fuck it, we're supposed to be standing up. We all know that sitting down is bad for you. Let's make people stand up, but I get your point. Okay, specifically when it comes to arms movement, there's a little bit of confusion around this. Everyone knows about gorilla arm, right? For the term before, you don't want to have the user go like this. The whole Minority Report thing, this is too tiring. That's true. However, this is tiring because the ball joint is now bearing the entire weight of your arm, of both bones. And that's why you don't want to do this. What humans do constantly all the time, you can find some pose like that right now, is this, which I call T-Rex arm. And humans can stay in T-Rex arm pose for like hours and hours and hours, which is why all of the creation tools now have world scale, because that way, no matter what you're doing, you can make it smaller and always work within T-Rex pose. As long as you keep the hands about like this, people can do this for, fairly indefinitely. And if you have world scale, that means they can put it down on the ground, be lying on the ground, painting, stand up and paint. But if you watch a sculptor sculpt, or a painter paint, almost always they end up in this kind of pose, and usually have something rest against as well. Yeah.
Thank you.
Sure. I think we're at time, so happy to talk about stuff more after too, but yeah, I think we're done. Yeah, thanks.